In this example, we want to look at a particle that's moving along a line and then say some facts about it. So assume a particle is moving along the line with the position s of t is t to the fourth over 4 minus t cubed plus t squared between t equals 0 and 3. I want to know the displacement, the average velocity over this interval, and then when, if ever, the particle changes direction. So the displacement here should just be s at the end point, so s at 3, minus the starting point, s at 0. Well, s of 0 here is 0, because I plug in 0 to every term, it just all goes away. This is 0. And then s of 3 should be 3 to the fourth, which is 81 over 4, minus 3 cubed, which is 27, plus 9, which is 81 over 4 minus 18. 18 times 4 is 72, so this ends up being a 9 over 4 for our displacement, which means that my average velocity, which is displacement over change in time, is 9/4 over 3, or 3/4. Now I want to figure out when, if ever, the particle changes direction, and that's me looking for the derivative and when that changes sign, or effectively where the derivative equals 0. We'll start by taking a derivative. We get that s prime of t is then t cubed, because the 4 and the 1/4 cancel out, minus 3t squared plus 2t. And I want to figure out when this is 0. I can do that by starting to factor it. This factors as a t times a t squared minus 3t plus 2. And this also factors as a t minus 2, t minus 1. So this is 0 at t equals 0, t equals 1, and t equals 2. So then between the interval of 0 and 3, it changes direction twice at t equals 1 and at t equals 2. We can also see this by looking at which way it's going at this point, because we want to look at whether it actually changes direction. So if I mark my points for 0, 1, and 2, we can see that between 0 and 1, the velocity is positive because I have two minus signs for the minus 2 and the minus 1. So I'll get a plus here. Between 1 and 2, I'll get a minus sign. After 2, I'll get a plus sign, meaning it goes from going forward to backward to forward. So it does actually change direction at t equals 1 and t equals 2. So you can analyze a problem like this to figure out where and when this particle is changing direction, as well as its displacement average velocity over that time interval.